Welcome. It is Thursday, September 3rd, and we are going to take a look at how we use trig identities to get the exact value of a trig expression. So an identity is like a rule. So, for example, you play a game. A rule is any rules of that game you could think of as like an identity for that game. It's something that's true. And it kind of directs you on what to do. So let's take a look at how this works with trig. Alright, so first thing we got to talk about is this idea of reciprocal. We've mentioned it quite a few times as we've been working through the 6 trig functions. But when we've got a fraction, let's say, writing its reciprocal is simply reversing the numerator and the denominator. If it's not a fraction, we can simply turn it into a fraction, and then again reverse the numerator and denominator, flip it in essence. Alright, it doesn't matter what it is, we just take whatever the numerator is, move it to the denominator, and take the denominator and move it to the numerator. So different examples here of writing reciprocals. If I said, well, I need the reciprocal of 2x. Well, 2x as a fraction would just be 2x over 1. So when I reciprocate it, it's going to be 1 over 2x. All right, 3 over x is already a fraction, so we just reverse the numerator and denominator. Same with this expression right here. Reverse the numerator and denominator. Okay, again, reverse the numerator and denominator. Again, now this x I can turn into a fraction by just putting it over 1, so it's 1 over x. And for the same reason, this would be 1 over y, and this would be x over y. Okay, so that's finding the reciprocal. Now, part of doing this was, well, what's the reciprocal do? Well, if I multiply a number by its reciprocal, let's see what happens. So, for example, if I took 2x and I multiplied it by 1 over 2x, well, when we multiply, we can cancel. So those cancel to both 1, and I'm left with 1. Okay, same thing here. These would cancel the 1, these would cancel the 1, and I'm left with 1. So a number or a value or an expression multiplied by its reciprocal becomes 1. Alright, so let's take a look at when we do this with trig functions. Alright, so we already know that if I take the sign is the y-coordinate if we're working on the unit circle. So if we know that the radius is 1, then if we had a point on that unit circle, then the cosine of that angle is equal to the x, and the sine of that angle is equal to the y-coordinate. Now, if this radius was something other than 1, like 2 or 3 or 4, some number r, then this becomes x divided by r, and that's y divided by r. And that's what we've been working on the last few lessons. Okay? Alright, so back here we've got the sine of theta is equal to y. So the reciprocal of y would be 1 over y, and we call the reciprocal of sine cosecant. All right, so these are reciprocals of each other just because these are reciprocals of each other. All right, now that's how we defined it when we were working on the unit circle and we wanted to find these. If we knew the y-coordinate, let's say the y-coordinate was 1/2, and we said, okay, what's the sine of that angle? And you said, oh, okay, it's 1/2. Then we knew that the reciprocal of that, cosecant, was 2/1. Okay, we just flipped them. All right. Now, that was this right here. Well, we can also define cosecant using the sine value. Because sine and y are the same thing, I can take this y out and I can replace it with sine. So another way of defining cosecant, as opposed to 1/y, the cosecant is the same as 1 over the sine value. And then the same is true for the remaining ones here. Okay, I know the reciprocal of x is 1/x. The reciprocal of the cosine we call the secant. Well, x and cosine are the same thing. So I can take out this x and I can replace it with the term cosine because they're equal. They're equal to each other. So secant can be written as 1/cosine. They're the same thing. All right, and then the same reasoning for cotangent. That's the reciprocal. If I did the reciprocal of tangent, okay, tangent, put it over 1, the reciprocal is 1/tangent. Okay, right there. So cotangent is the same as 1/tangent, just like it's the same as x/y, because tangent is y/x. All right, now what we're going to do is we're going to do the same thing we did right above this here. When we take a value and we multiply it by its reciprocal, we know that it's going to equal 1. All right, so if I look at this, sine and cosecant, these are reciprocals of each other. Just like above it, 2x and 1/2x, these are reciprocals of each other. So when you multiply a number and its reciprocal, or a value or an expression, so when I take an expression and I multiply it by its reciprocal, I know that that value is going to be reciprocal. I know that that's going to equal 1. So sine and cosecant, they're reciprocals of each other. So when I multiply those, it's 1. And there could be anything I want in there. So in this one I had theta. Well, what if I put 80 degrees in there? Well, sine and cosecant are reciprocals of each other. And when you multiply reciprocals of the same angle, then those are going to become 1. So I don't need a calculator or anything here. I can simplify this strictly based on what I know about reciprocals. And you could have radians in there. You could have the sine of pi/3 times the cosecant of pi/3. And you recognize, well, hey, those are reciprocals. Okay, the angles are the same, same angles, or the same measure, it's just radians, so I know that that's going to equal 1. So what we're looking for here is 1, come back here, easel flip, get back here. All right, those are reciprocals. These are the same, so my answer is going to be 1. And that's true for all of these reciprocals. Same angle, so that equals 1. So all of these are doing the exact same thing. Secant and cosine are reciprocals. Now that's got to be multiplication. If it's addition, that's something else. Okay, but if it's multiplication, it's when we take an expression times its reciprocal. That's when we get equal to 1. So up to this point, what we've shown is if we take an expression and we multiply it by its reciprocal, then we're going to get 1. So it goes to say if we took an expression and we multiplied it by the negative of its reciprocal, we would get -1. All right, now you'll see how this plays out here in just a second. All right, so here is a 338-degree angle, and the difference between these two right here is 22 degrees. Okay, the second angle in this drawing here is a 22-degree angle. Okay, so that's 22 degrees. All right, so these two numbers aren't the same like they were up here. If they were, then we could just say, hey, that we know that this thing is going to equal 1 because these two trig functions are reciprocals. And if these two angles were the same, then we know that this thing was going to equal 1. But those two numbers aren't the same, but they are related. Okay. So if you recall, the sine is the y coordinate. Right? So in this drawing here, okay, the y coordinate is going to be whatever, how far this point is from the x-axis. That's the y coordinate. Okay, and the y coordinate for 22 degrees and you can see that these two lengths, this length and that length, are the same because both of these are 22-degree openings. Alright, so if I was going to describe the y coordinate of this as y, then this coordinate would be -y. So basically what I'm doing on this, the sine of 338, okay, that would be the same as whatever that value is. So that would be some number negative. Then when I do the cosecant of 22, cosecant 22, that's going to be the y value, but it's going to be 1 over y. So when you multiply these two, you're going to get -1 instead of 1. Okay, next example, we got 440. So we got reciprocals here, but we want to take a look at how do these angles compare. If they were both 400 or if they were both 40, then we'd know right away that the answer would be 1. Okay, so the cosine of 400 is going to be the x-coordinate of this point here. Okay, now that x-coordinate is whatever this length is until I'm right under that point, because that would be its point. That point's x-coordinate right here. This is the y-coordinate. That's the x-coordinate that I highlighted in green. All right, so the cosine of 400 is whatever this is. So it's some number x. Now, if you did the secant of 40, okay, the secant is the x value, but the reciprocal. So in this particular case, when we'd multiply these, we'd get x times 1 over x, and we know that that is going to be equal to 1. So here they were -1, because these angles were really opposite each other. These end at the same place. So we can think of them as essentially the same angle, because this angle here would have the same x-coordinate whether it was 400 or whether if it was 40. All right, 215 and 35. So 215 degrees that's 215. So that point is going to have some xy coordinate. And to get its tangent, okay, the tangent is equal to the y coordinate divided by the x. Okay, now 35 degrees. So yeah, 180 to that, and then 35. Okay, and that's going to have an x and a y coordinate. Now the thing is, these are going to be the same, except these are going to be negatives because they're in the third quadrant, and these are going to be positives. But their distances, their lengths are the same. Okay, so if this was the end point, okay, how far it is right there, that y value is going to be the same as this y coordinate. Except this one's going to be negative and that one's going to be a positive. Then the x coordinates, that's the x coordinate, and this x coordinate, since it goes to the left, is going to be negative. Alright, so the tangent is negative. It would be negative y over negative x, which becomes positive y over x, times the cotangent over here is, this is going to be x over y. And when you multiply those, the y's are going to cancel, the x's are going to cancel, and you get 1. All right. Let's see what we got on these next few here. Now we get into some ratings. Okay, the sine of pi over 6. So this is divided into pi over 6 pieces. There's 6 pieces on the top, and there's 6 pieces on the bottom. So the sine of pi over 6 is the y-coordinate of that point. That right there is the same as the sine of pi over 6. Okay, now 13 pi over 6. Well, if I counted all the way around this, that would be 6, that would be 12, that would be 13. This is going to be, that's the y-coordinate, okay? 13 pi over 6, if I'm going to do the cosecant of 13 pi over 6, well, that means you take this y-coordinate, but you put it under 1. So this pi over, this is y, and this is 1 over y, but they're both the same y, and so when you multiply those, you get 1. All right, let's try next one. Cosine. So this is going to be, these are reciprocals again. All right, and cosine is the x-coordinate. Okay, pi over 11. So I took a circle and I divided it into 11 slices on the top half, 11 slices on the bottom half. Each slice is pi over 11. Okay, so the cosine is going to be the x-coordinate of this point. Okay, that's the cosine of pi over 11. It's going to equal some number x. All right, now 23 pi over 11. Well, if I went around, that's 11, 22, 23. It's the same thing. So it's at the same place. It's the same terminal point. So the secant of 23 pi over 11 is the same x-coordinate, but 1 over it. So this really just becomes x. This is 1 over x, and I'm going to get 1 again, because they're the same angle. They end, it's the same, it ends at the same place, I should say. All right. Okay, pi over 7, the tangent. So now here's a circle cut into pi over 7 slices. Okay. So the tangent of that, the tangent of this angle is going to equal, the tangent of pi over 7 is going to be the y-coordinate divided by the x-coordinate. So y divided by x. Okay, now the cotangent of 15 pi over 7. Well, that's 7 pi over 7, 14 pi over 7, 15 pi over 7. So cotangent is x over y. So these are the same point on the circle. I ended up at the same place. So this one is x over y, and those are reciprocals, and when I multiply them, I get 1. So that's the work on reciprocals. All right, the last part of this lesson has to do with what is known as the quotient identities. So we know that tangent is equal to y over x. Well, y is the same as sine, so I can take out that y and replace it with sine, and then I can take out this x and replace it with cosine. So we can also define tangent by the cosine divided by the sine. And then the same argument works for cotangent, except now it would be x over y, or cosine over sine. All right, so the tangent of 20 degrees. I don't want the value. I'm just going to write it a different way. Okay, so I'm not asking you to find the exact values on these. I didn't write any instructions here. I probably should have. Okay, but this would be this. I could rewrite that as the sine of 20 divided by the cosine of 20. Okay, those two expressions are equal to each other. They're the same. Just like with the cotangent of 15, I could rewrite it as the cosine of 15 now is the numerator, and the sine of 15 degrees is the denominator. All right. Now this is, you're just working backwards. Okay. You're starting with the quotient. Quotient is, a fraction is a quotient. It's the top divided by the bottom. That's why these are called quotient identities. This is really sine divided by cosine. So this would be equivalent to the tangent of 10 degrees. Sine over cosine, these two angles are the same, so this would be the equivalent of tangent of pi over 4. This is cosine over sine, 80, so this would be equivalent to the cotangent of 80 degrees. Cos over sine, that's cotangent, and this would be the same as the cotangent of pi over 6. So sometimes we have to rewrite expressions so that we can do stuff with them. Well, one way of rewriting a tangent is rewriting it as a sine and a cosine, and rewriting a cotangent as a cosine divided by a sine. So if we look at these last two examples here, these are really the same thing. I can take this and I can rewrite it. What I just circled there is the same as the tangent of 20 degrees. Now we're subtracting them. So whatever, these are the same, so if I subtract the two of them, I'm going to get 0. Okay. I can take this quotient and I can rewrite it as the cotangent, because it's cos over sine, of 35. These are the same. Now you couldn't do that if those values were different. So one of those was 35 and let's say the other one was 85, then no, you can't rewrite it. Okay. But now cotangent 35, and you're going to see you're going to get the same thing. It's going to simplify to be 0. All right, so for the assignment for this, you're going to be doing Math Excel 16. Okay, and instead of there being 2 days, because most of these go pretty quick, this is due Friday night by midnight. So you have 1 day to complete this for on-time credit. All right, that takes care of it, and I'll see you next time.